In this segment, I'm going to go over the basics of electric charge. The Greeks were the first ones to discover a phenomenon where if they rubbed a piece of amber with a piece of fur, they found that the amber would attract small objects. This would have seemed a bit like magic to them, but how do we explain it nowadays? How does physics account for those forces? Well, the answer is we propose a property that certain materials have called charge. And there are two types of charge, which you're probably already aware of, positive and negative. And there are two everyday particles that carry these charges. There's the proton, which carries the positive charge, and the electron, which carries the negative charge. The amount of charge on the electron is the same as the amount of charge on the proton, except the charge on the electron is negative. We call this amount of charge the electron charge, and we give it the symbol E. The charge on the electron is the smallest amount of charge you can have. You can't have half an electron worth of charge because you can't have half an electron. Also, you can only have multiples of this amount of charge, since all objects are made up of protons and electrons. Charge is given the symbol Q, and it must always be a multiple n of the electron charge. Well, how do we measure charge? We could count up all the protons and the electrons and find the difference, and then we would have the net charge on an object. But since everyday objects are made up of billions and billions of protons and electrons, it's simply not practical to count up all the proton and electron charges and find the difference. So instead, we use a big amount of charge as the standard unit. That big unit is called the coulomb and is given the symbol C. It would take 6.24 times 10 to the 18 electrons to make up 1 coulomb of charge. Or, looking at this a different way, you could say that each electron or each proton has only a tiny fraction of a coulomb of charge. 1 electron has 1.602 times 10 to the minus 19 coulombs of charge. I like to think of a coulomb as a little bucket full of electrons. It's this convenient amount. Like a kilogram of material, a coulomb of electrons is a nice, convenient way of talking about a standard unit of charge.